That's harassment now. Be good. Open the door, please, Bruce. Thank you.
Nobody here.
I heard it. Open the door.
Emotional state.
That's worse.
See, I told you.
Crazy.
Huh?
There are rumors about you.
And you're like
Dude!
Dude.
I love these ones.
Me too.
Yeah, well,
It's cold, I'm jealous.
they're for me. Thank you.
That's mine.
Oh, sorry. Well, thank you then.
Greatest ever.
True. Okay, continuing. We're going to look at something
Odd.
not too difficult. Odd and even functions.
Even.
Chew. We're continuing. Okay. Guys, please, continuing. So I'm asking you, some of you will know these words, odd and even. What do they mean?
1, 3, 5.
Yeah, for numbers, they mean 1, 3, 5. But they have, a different meaning when we're talking about functions. Does anybody know their meaning when we talk about functions? No, you're close. You're close. We do call x cubic and x5 odd functions. X squared, x4, x6 even. But more generally, what makes it even or odd? In the formula. Not necessarily. Oh, good. Not this. Good guess, though. Good guess.
Or the domain is...
It has to do with the graph if it's like this. Graphs which look like this which are the same on the left and on the right. So for example, if fx equals f of minus x, we call that even. So this is why x squared, x4 and x6 could be even. What about odd?
Exactly.
Fx equal minus
Fx equal.
That's the one. No, Jerry said it. Say it again, Jerry.
Fx equal minus fx.
No.
No, not quite actually.
Minus Fx equal s minus x.
Okay. F minus x.
Equal minus fx.
Yeah. So the graph would look like this.
Yes.
That it would be the same in opposite corners like this, whereas for even it's the same like this, or underneath as well, it could be. So we call this one odd. So let's have some examples. Examples here would be fx equals x squared. An example here would be, for example, fx equals x cubed. Well, let's have something more interesting. What would be a more interesting example? Well, in fact, cos x is even.
Yeah.
And sin x is odd. What about ex? Ex. Yeah, so it is possible to have neither. So it could be odd, it could be even, or it could be none of them. Neither. Okay, so your choices are either even, odd, or neither. Oh goodness, it could not be both. Is neither. Log x? Log x? Neither. 1 over x?
Huh?
1 over x.
Odd.
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 1 over x squared?
Even.
Even. Tan X.
ODC.
Odd.
ODC.
You can say odd. Root X. Nope. Nope.
I know.
Neither. Root X has no values in the negative.
Yeah.
So
Neither.
x squared plus 1. X squared plus 1.
Even.
How you know? I'm just guessing.
Well, this is the thing. How can we know? So let's have a look at an example of how we can know. Let's have a look at the worksheet and pick out an example. Let's take something like this now.
What?
Let's take an example. fx equals, let me make up an example. 2 sine x 2x plus pi over 4. Now, is this even or odd? We don't know. We don't know because we know sine x is odd and cos x is even, but we don't know what happens for this graph. In fact, the only way to know is to graph it. So let's graph it very quickly. This is equal to 2 sine 2x plus pi over 8. So we have, remember how we do this? Min, max, start, end. Minus 1, 1, 0, 2 pi. Okay, so what does the 2 do? It goes minus 2, 2, 0, 2 pi. Who remembers what this 2 does? No? Nobody? It contracts. So that's 0 pi. Nothing happens here. And the pi over 8? No, minus pi over 8 and 7 pi over 8. You move it to the left. So this is neither. Because if you were to look at the graph, it starts at minus pi over 8. Starts at minus pi over 8 and finishes at 7 over 8 pi. So, and it is sine. So sine starts at the top, middle, or bottom.
Middle.
Sine starts the middle. Oh. Sorry. Help me out here. It's clearly, flip. It's not odd or even because if you look at the graph, it's not. It's not symmetric. It's not symmetric because if it was symmetric when it reaches this axis, it should then have a mirror image. And it's not odd because for odd it has to pass through the origin. Yeah, because I said for odd it has to be the same in the opposite corners, which kind of forces it to pass through the origin. Say again? Sine passes through the origin. If you look at the sine graph, it goes like this. So it's the same in opposite corners. Look, if I do f of 1, I get a big number. If I do f of minus 1, I get a number but not as big. I should have gotten minus the value I did for the 1. So this, from the graph, we can see is neither. Yeah?
If there is suffer,
Huh? If there's a what?
many.
The circle, no, that was just a point. I'm saying it doesn't pass through the origin. Yeah? Yeah, what about it? Even or odd? Good question. Well, technically I guess it would be even. Well, but you see, they wouldn't ask you this for a many to many graph. I should specify a word here. You notice how I called this lesson a even and odd functions. Okay, functions are, guys, I think this is something I didn't say. It's something I didn't say, and in the exam they're often very careless about this. But for me, when I say a function, I mean something which is only 1 to 1 or many to 1. When I use the word function, I'm narrowing my usage down to only these two types. Now, with that said, in the exam they misuse this term, I feel. Sometimes they say function when they refer to something which is many to many, which I don't really think they should, because a function should be only 1 to 1 or many to 1. It should be clear. The problem with your circle example is, because it's many to many, when I say fx equals f minus x, you're confused about what values to take. For me, function means this. In the exam it should mean this, although they're careless sometimes with the terms. Okay, so we can check by the graph. That's one way to check.
How we tell?
What?
We have the graph. How we tell if it is odd or?
Well, first check if it's even. Even's the easiest to tell. It has to be a symmetric mirror image. If it's not this, it could be odd. Odd means it must be the same in the opposite corners, passes through the origin. If it's not this, then it's neither of them. So if you think about the graph x cubed, which is odd, and sine x, which is odd, and tan x, which is odd, all these graphs pass through the origin. That's a requirement of odd functions.
Could we prove it?
Proof? Yes. Well, the other way to do it. Let's have a look. No, let's have a look. Let's have a look. Can I scroll down? Take an example like this. The first one, even or odd?
Even.
Yeah.
Even. The second one? Neither. Because this one, its graph looks like this, which makes it even. And this one, its graph looks like this, which makes it neither. Yeah?
Yeah.
So, how can we check? Well, there is a way you can check. You can just check what happens if you calculate f of minus x. If you can get f of x, then it's even. If you can get minus f of x, then it's odd. So let's check it here. What's f of minus x? That's equal to minus x squared plus 1, which is equal to x squared plus 1, which is equal to f of x. So that makes it even. Here, what's f of minus x equal to? That's equal to minus x squared minus 3 times minus x plus 2, which equals x squared plus 3x plus 2, which does not equal f of x, and it also does not equal minus f of x. So this one here is neither. You could actually do this method on the previous example, provided that you have some trigonometry rules which you've not done yet, because we do not have trigonometry rules to simplify down this formula. But some people maybe know the rules already. They're the rules for sine A plus B. We'll look at that later, but this is another way to do it. Now, why is it useful to know if it's even or odd? Let's have a look. It's actually quite useful to know for integration. We'll see now. Can I scroll down? Yeah? Okay, take this example here. What is it? Sine, we said, is odd, didn't we? Yeah, sine is odd. Okay. Now, what's this equal to? No, what number value? How would you integrate this? What would you do to integrate this? I have no idea, but I know what the answer is.
0.
Yeah. Why?
1 and minus
Good guess.
1. And minus 1.
That's part of the reason that makes it 0. Because of this. If you have a function which is odd, let's say something like this, okay, and let's call this function y equals odd x, some odd function like x cubed or whatever, then if I integrate from minus a to a, this odd function, I know the answer must definitely be 0, because this is minus a, this is a. This area will be the same but negative of this, so the total would be 0. Now, what happens if I try to do something which is even? So let's say y equals even x. Yeah, what would it be? You would say minus a to a even x dx. Forgot my dx here. Yeah, what would that equal, Jerry? What would this equal? Double what? Yeah. That if you integrate this, that will be exactly the same as twice this, because it's even. So knowing if a function is odd and even, very useful when the limits are in this form. It's extremely useful when you have this, because you know that this should always equal 0. It's extremely useful. Think about this now. It's also easy to know if a function is even or odd if you're multiplying many functions together, if you know what each one is. So for example, can I scroll down? Well, to here?
Yeah.
So suppose I have some function f of x which is even, and I multiply by another function g of x which is even, and I multiply by another function h of x which is even.
Even.
The total must be even as well.
Yeah.
Because if I was to put a minus here, because each of these are even, for example, what does fx equal? Or what does f minus x equal?
Okay.
Yeah, g minus x?
Yes.
Here. And h minus x?
H.
So if I have 3 even functions, then the total will be
Even.
What about if I have 2 odd functions?
Even.
Even, yeah. What about if I have 3 odd functions? Odd, yeah.
Oh.
three odd functions would make an odd, because f minus x, g minus x, h minus x would equal minus 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 fx, gx, hx,
Oh.
which is minus fgh. So three odd functions would make an odd.
Oh.
What about an even multiply an odd?
Odd.
Odd. Yeah. Yeah. Makes sense?
Odd.
Actually, I don't really know for certain that this is odd, so I'll just change it to guarantee it's odd. So this function is odd, because this is odd and this is odd. This one is odd as well for the same reason. This is odd and this is odd. And this one here is odd because this is odd. But what about an odd over an odd?
Even.
Odd over odd? Even.
Even.
fx over gx. If both of them are odd, both minuses come out making even, a plus. But an even multiplying odd, so the minus comes out, so it'll be odd. Yeah, so this in total was odd. So even and odd, I seem like simple ideas. It's just, it's just this. But it's actually very useful, because a lot of useful functions are even or odd, like x squared, x cubed, sine and cos. And even and odd is actually important in what we were talking about last week with the Fourier analysis for the waves. So, can I scroll down? I just have a look at the book. So in the first question you have to decide if it's even or odd, or if it's periodic actually. You remember from semester 1 what periodic is? What's periodic? Sine. It repeats. So a quick look here, you can kind of see straight away which ones are the periodic ones. Sine and cos. These are all periodic. Now just because it's periodic doesn't mean it's not even or odd. Like for example, sine x is odd and also periodic. And then this one here you just want to practice which are even and which are odd. So f and g are even, h and I are odd. So this is even by even. So this one here would be an even function. This one here, even by odd, would be odd. This one here, odd by even, odd, and this one here, odd by odd, which is even then. Okay. So we're just practicing here. Some of them it's clear, but some of them you'll need to maybe draw a graph. Like let's have a look at the first one here. Even or odd?
Even.
Even. Yeah. The second one? I think it's neither. The second one. Here. Even or odd?
Even.
Neither, yeah. This one?
Neither.
No. Odd. Because if you put minus x in, you can take the minus out and have minus f of x at the end. Can you see why it's odd, Sean? No. Can people see why this one's odd? Let me show you really quick. I'll do something similar. X cubed plus x, that's f of x. What's f of minus x? Minus x cubed plus minus x, which is minus x cubed minus x, which is minus x cubed plus x, which is minus f of x, which makes it odd. Sean, is that okay now?
Okay.
Yeah? D, odd or even, or neither? Well, we don't know, but I think it's probably neither. The next one? No. Is it? It is even, yeah. Because of the square in the power.
Easy.
You could check it out, like for example, if I have ex squared as fx, then what's f of minus x? That would be e minus x squared, which is, so this one is even. But what about this one? Neither. What about this one? even neither? I think this one's a neither. Because you can't pull the minus out in front. You can only pull the minus out of the power, which is no good. So like here, fx equals this. F minus x equals e minus x cubed, which equals e minus x cubed, which does not equal minus e x cubed. And that's what you would need it to be for it to be odd. Okay, so it's, sometimes you have to think a little bit about this. It's not immediately obvious. Oh yeah. Why do I make such tricky questions? These are tasty. I like it. Okay, so I'll let you try the questions for a few minutes and then we'll have physics, okay?
2 hours.
No, 1 hour physics. Yeah, so I just want you to try some, because you haven't tried anything this morning yet for the math. So if you can try some questions from both worksheets, which are on Moodle. And then, once you try for 10 minutes, you can take a break then.
The break again.
Well, no, I just figured you'd be whining for a break, but I don't have to give you one.
Okay.
No need for a break then?
No, I
Oh, okay. Don't misunderstand me. Okay. Can I close this?